Have you ever wondered if the fundamental physics you learned in school is actually based on a massive collective optical illusion?
It's a pretty wild thought, honestly.
Right. Because today we are completely dismantling how you look at space and time.
We really are.
And our guide for this, perspective shift is a highly unique, pretty dense, and deeply philosophical 54-page blog draft. It's titled Mr. Einstein's Slacking 149 Ideal State.
Which is quite the title.
It really is.
Right.
But the author makes this radical claim. They argue that modern physics, specifically Albert Einstein's special relativity, is trapped in a conceptual maze.
Right.
And it's because it confuses mathematical blueprints with the physical reality of how our eyes actually observe the universe.
It's the kind of premise that really forces a hard reset on how you process information.
Yeah.
I mean, we rely on these foundational mathematical truths to make sense of the world, right?
Yeah, absolutely.
So when someone suggests those foundations are built on, well, a structural misunderstanding of human vision, you have to either dismiss it entirely or be willing to question everything from the ground up.
Okay, so let's unpack this. Where does this massive scientific misunderstanding actually begin? Because the author frames this whole crisis as a battle between two different types of eyes.
Yeah, that's the perfect place to start. To really grasp the critique, you first have to visualize two conflicting frameworks of reality. The first is what the author calls the God's eye.
Which is like the classic Cartesian coordinate system, right? The standard X, Y, and Z axes we all had to draw on graph paper in middle school.
Exactly, yes. It's a Newtonian framework. So it's this purely mathematical space where the concept of now, a moment where time equals zero happens everywhere simultaneously.
Right.
So if it's exactly noon for you at the origin point, it is exactly noon across the entire infinite grid at the exact same moment.
So it's like looking down at a static map spread out on a table. Every city, every road on that paper exists at the same time. The paper doesn't have a time delay.
Spot on. But the physical universe we actually inhabit, it doesn't operate like a piece of paper. We live in the camera eye.
The camera eye, okay.
Right. And this framework relies on electromagnetic waves, primarily light to gather information. And light, while incredibly fast, it takes physical time to travel from an object to your retina.
Right, there's a speed limit.
Exactly. The author uses a brilliant, really grounding example here with thunder and lightning. So imagine a lightning strike hits a tree far off in the distance. The fire, the flash of light, and the concussive sound all occur at that specific tree at the exact same physical moment.
But if I'm standing a mile away at what the math would call position 0, my body doesn't experience it that way at all. I see the flash first, and then the boom of the thunder hits me, seconds later.
And that friction point is everything. An observer standing a mile away is living in a different now than the tree.
Oh, I see.
Yeah, the observer detects those simultaneous physical events as separate, staggered events because the environmental information took different amounts of time to travel to their senses.
So it's like the difference between looking at the raw code of a multiplayer video game, where the main server knows exactly where every single player is instantly, versus actually playing the game on your monitor where you have ping delay or lag.
That is a great way to put it.
The main server has the God's eye, but you, the player, only have the camera eye.
But wait, here's where I need to push back on the author's premise a bit.
Sure.
Because surely physicists know light takes time to travel. I mean, the speed of light is literally the bedrock constant of modern physics.
Yeah.
Why does this ruin the whole math system?
Well, what's fascinating here is you've hit on the exact contradiction the author's trying to expose.
Yeah.
Physicists absolutely know about the delay of light.
Right.
But the text argues they still try to force these delayed, lagging electromagnetic phenomena onto that instant Cartesian God's eye map.
Yeah, they take visual information that is fundamentally distorted by travel time, and they plot it onto an XY grid that assumes simultaneous existence. It's a categorical error. They are mistaking the mathematical map for the physical territory.
So they're treating the delayed signal as if it's happening right now just because they can draw it on a graph.
Exactly. And to prove just how deeply this lag messes with our perception of reality, the author applies this logic to one of the most famous philosophical debates in the history of science.
Okay, I'm intrigued.
Let's look up at the night sky.
Oh, you're talking about the quantum mechanics debate. Albert Einstein versus Niels Bohr.
Yeah, a legendary disagreement. Einstein was pushing back against the bizarre probabilistic implications of quantum mechanics. He famously challenged Bohr with a question along the lines of, do you really believe the moon does not exist when you aren't looking at it?
Right, Einstein was defending objective reality, this idea that the universe exists continuously, independent of our observation.
Right.
Which, I mean, if you're listening to this right now, sounds like common sense. If I close my eyes, the moon doesn't just blip out of existence like some rendering glitch.
Well, it sounds like common sense if you live in a God's eye framework.
Yeah.
But the author calls this entire debate a categorical error from both of these geniuses.
Wait, really? Why?
Because physically speaking, from the biological perspective of the camera eye, you never actually see the moon.
Here's where it gets really interesting. Wait, what do you mean I don't see the moon? What am I doing when I look up at the sky at night? Am I just recording a photon collision on my eyeball?
That is the only physical event happening to you. You are experiencing a highly localized interaction.
That's wild.
Electromagnetic waves, photons, travel across space and trigger a chemical reaction on your retina. That retina strike is your only physical reality.
Okay.
And because the moon is about 380,000 kilometers away, those light waves are a 1.3-second delayed record of the past. You are not experiencing the moon now. You are reading an old piece of mail.
Okay, hold on. Let me sit with that for a second because that breaks a lot of things.
It does.
If I am only ever interacting with 1.3-second-old light and I can never access the actual present moon, how does anything function? What about gravity?
Oh, good question.
Right. If gravity is pulling the oceans based on where the moon was 1.3 seconds ago, visually, wouldn't orbits degrade? How does the author reconcile physical gravity with this visual light delay?
Well, that is the brilliant trap of the human mind. See, gravity also propagates at the speed of light. So the physical influence and the visual information actually arrive together.
Oh, okay.
But our brains just don't like dealing with lag. We construct a high-level cognitive delusion, a mental map, to sync everything up.
A delusion?
Yeah, we intuitively build a mathematical Cartesian space in our heads to assume the physical moon is sitting there right now, simultaneously with us. We reverse engineer a present reality from old data.
Wow.
So the author's critique is that both Einstein and Bohr were arguing over a shared illusion.
So Einstein thought the moon was definitely there right now, and Bohr thought the moon's state was undetermined until looked at. But both of them were acting as if their eyeballs had instant remote action access to the moon itself.
Exactly.
They completely ignored the 1.3-second biological lag in their philosophical framing.
They were trying to debate the God's eye territory while physically trapped inside their camera eye biology.
Okay, so a 1.3-second delay for a stationary moon is one thing. But what happens when things are moving? I mean, if everything I'm seeing is just a delayed signal, is the image lagging behind the physical object in a way that distorts it?
Oh, absolutely.
Let's talk about the thought experiment with the moving train, because that really dives into it.
Yeah, this is where the geometry gets incredibly weird, and it proves why the Cartesian grid fails us. The author introduces a geometric breakdown of a moving train to show how motion weaponizes this lag.
Weaponizes the lag. I like that.
Imagine you, the observer, are standing perfectly still at the origin point of a graph. Coordinates 0, 0, 0.
Got it. I'm standing still.
Now imagine a train with a total length of 10 units moving along a straight parallel track directly in front of you. Let's say the track is at a distance of y equals 1.
So a train sliding past me horizontally just 1 unit away.
Right. The author breaks down the specific math of what your camera eye actually captures in that scenario. If you look straight ahead at position x equals 1 on that track, the math dictates your angle of sight is exactly 45 degrees.
Okay, 45 degrees.
But if you shift your gaze further down the track to where the back of the train might be, say at position x equals 11, the angle shrinks drastically to about 5.19 degrees.
So if you're listening right now, try to picture this. It's like standing on a sidewalk watching a ridiculously long limousine drive by.
Yes.
The front bumper right in front of you is at a wide angle. The back bumper way down the street is at a tiny, narrow angle. And crucially, that back bumper is physically further away from my eyes than the front bumper.
And that distance is the key to everything. The distance from your retina to x equals 1 is much shorter than the distance from your retina to x equals 11.
Wait, so what does this all mean? If the distance is longer, and we know light has a strict speed limit, then the light bouncing off the back bumper takes longer to reach me than the light bouncing off the front bumper.
You see where this is going.
Which means I'm seeing different parts of the limo from entirely different moments in history.
Exactly. If we connect it for the bigger picture, that is the mind-bending realization the author is driving at. because the light from the front and the back of the train takes different amounts of time to travel through space. The single cohesive image that hits your eye at the exact same moment is actually a collage of different pasts.
The back of the train I am looking at is literally older than the front of the train I am looking at.
Yes, you are not seeing a single present train. The visual image your brain constructs is a distorted temporal mosaic.
A temporal mosaic.
Right. Because the train is moving, the older light from the back of the train represents where the train was, while the newer light from the front represents where the train is. The object isn't just moving through space, from your visual perspective. It is twisting through time.
So the train I see in my mind's eye, the one that looks perfectly solid and normal, is a biological rendering trick. I'm taking a whole bunch of delayed postcards sent from different distances, taping them together into a collage and telling myself, look, a train happening right now.
A biological rendering trick is a fantastic way to put it. And this specific visual glitch, this patchwork of the past, is exactly what the author claims tripped up the greatest scientific minds of the 19th and 20th century.
Oh, wow.
Yeah, they fail to account for the fact that a moving object viewed from a single point is a temporal mosaic. And this leads directly to the author's critique of special relativity and the famous Michelson-Morley experiment.
Right, the Michelson-Morley experiment. This is the one that tried to measure the speed of light on a moving platform, right? Using an interferometer. But for those who might not have a physics degree, what was that machine actually doing and why did it break the math?
Well, an interferometer is essentially a device that splits a single beam of light into two separate beams, sends them down two different arms at 90-degree angles to each other, bounces them off mirrors, and brings them back together.
Like splitting a laser pointer, sending one beam north and one beam east and waiting for them to bounce back to the center.
Exactly. Because the Earth is moving through space, the physicists use their God's eye Cartesian math to calculate exactly when the light beam should return.
Right.
They assumed that because the arms were the same length, the light should travel the same distance. But because the entire device is moving, the actual path the light takes, from the perspective of a static observer, is a diagonal zigzag.
Ah, I see.
So the light took longer to return on one axis than the other. The return times didn't match the mathematical blueprint.
Because they were using a map that assumed now was everywhere at once, they completely ignored the fact that their own measuring devices, the light itself, were bound by the lag of the camera eye reality.
Precisely.
So how does the author of our source explain this specific failure? There's a fascinating part in the text where they use 3D modeling software, right?
Yes. The author introduces a brilliant proof using Blender 3D software. And it's really important to understand why they use 3D software. A 3D rendering engine doesn't just draw flat pictures.
Right.
It mathematically calculates the precise travel of light from a light source, bouncing off a 3D object, and entering a specific virtual camera lens. It is the perfect simulation of the camera eye.
So the software inherently calculates the time delay.
It does. So the author sets up 3 different virtual cameras to view the exact same moving light pulse. And they actually name these cameras after historical Chinese figures to give them distinct identities.
Oh, that's fun.
Yeah, camera 1 is Hanjin, located right at the origin point 000. Camera 2 is Xiaohe, offset down the y-axis at 0, -10, 0. And camera 3 is Liu Bang, the king, looking down from a godlike perspective, high above at 0030.
Okay, so 3 different observers at 3 different coordinates watching the exact same light experiment happen.
Exactly. And what the Blender render engine proves is that if you try to use a single, flat Cartesian XY plane to calculate the travel time of light for all 3 of these observers, the math entirely collapses.
Why is that?
Because Xiaohe is 10 units away. So the light takes a different, longer diagonal path to reach his camera lens than it does to reach Hanjin at the origin. The delay is fundamentally different for every single observer based on their specific coordinates.
So a flat piece of graph paper simply cannot reconcile 3 different simultaneous truths about when the light arrived.
It can't. So when Michelson and Morley found that their light return times on the x and y axes didn't fit the Cartesian math, physics had a massive crisis on its hands. Their map was broken.
So what did they do? Did they throw out the Cartesian map and draw a new one?
No. And this is where the author's critique gets truly scathing. Instead of abandoning the flawed Cartesian grid, physicist Hendrik Lorentz and later Albert Einstein in his framework of special relativity, they applied a mathematical workaround.
A workaround?
Yes. They introduced the concept of Lorentz contraction. They theorized that the moving apparatus itself, the physical space, literally shrinks in the direction of motion.
Wait, I really want to make sure I understand this and that you listening understand this.
Yeah.
Instead of realizing their mathematical grid was flawed by light delay, they just decided the physical universe was shrinking to make the math work.
That is the author's exact argument. They literally refer to Lorentz contraction as a patch.
It sounds exactly like a software developer finding a foundational bug in their video game's collision detection, and instead of rewriting the physics engine, they just release a massive patch that deletes the player's legs so they stop bumping into things.
That is an incredibly apt metaphor. To the author, shrinking space and time dilation are not physical realities of the universe. They are the bizarre, convoluted mathematical consequences of trying to force delayed camera eye phenomena onto a rigid, instantaneous God's eye grid. You are trying to patch a fundamentally broken render engine.
It's like trying to force a round peg into a square hole, but instead of just getting a round hole, you aggressively redefine the concept of wood to explain why it doesn't fit. So, if the Cartesian grid is the square hole, what is the author's ideal state solution? How do we fix the map?
The author's solution is to abandon the square Cartesian grid entirely when dealing with electromagnetic phenomena. Instead of a flat grid of squares, we should use a spherical screen.
A spherical screen, okay.
Imagine concentric circles radiating outward from the observer in every direction. But crucially, the radius of these circles isn't measuring physical distance in meters or miles. The radius is measuring time delay.
Okay, let me visualize that. So radius equals time.
Think of a circle with a radius of exactly 1 second. That circle represents all the physical locations in the universe where an event happened exactly 1 second ago from the observer's specific perspective. It is a sphere of temporal delay.
Oh, wow.
Right. If you map moving objects onto these temporal spheres instead of a static physical grid, the author argues that all the mathematical contradictions vanish entirely.
You don't need physical space to miraculously shrink. You don't need time to dilate.
Exactly. You just need to accurately map the delay of information reaching the local observer. When you map reality using spheres of time, you are finally mapping the reality of the camera eye, not the mathematical illusion of the God's eye.
That is absolutely brilliant. I mean, it is incredibly disorienting to realize that the visual world around us is a temporal collage, but it makes complete intuitive sense when you step back from the dense math and just think about the biological mechanics of how vision actually works.
It really does. It serves as a powerful reminder that our models of reality are just that. They're models. The text quotes the famous adage, "The map is not the territory." When the map stops making sense, and you have to start inventing concepts like shrinking space to make the math work, you shouldn't assume the territory is broken. You should probably just draw a better map.
This has been an incredible journey. If you are listening to this right now, whether you are prepping for a technical meeting, trying to innovate in your own field, or you're just insanely curious about how the universe fundamentally operates, this deep dive is a masterclass in challenging your foundational assumptions.
Absolutely.
It shows how even the most brilliant people in human history can get locked into inventing overly complex workarounds simply because they refuse to change their underlying framework. They patch the code instead of rewriting the engine.
It certainly forces you to audit the paradigms you accept without question in your own life, in your own disciplines. We all have our own Cartesian grids that we cling to when we should be drawing spherical screens.
Absolutely. Which brings me to a final thought I want to leave you with today. We've just spent this entire deep dive establishing that everything you see right now is a patchwork collage of different pasts, based entirely on how far away it is from your retina. A true simultaneous present doesn't actually exist in your visual field at all. So, what else in your daily life are you assuming is happening right now when it is actually just a delayed signal from the past? Think about the business data you use to make decisions. Are you reacting to a dashboard metric that represents reality as it is today, or reality as it was a week ago when the data was logged?
That's a great point.
Think about your relationships or the news you are reading on your timeline. Where else are you trusting a God's eye illusion of instantaneous truth when you are actually trapped in the lag of the camera eye? Something to mull over today as you look out at the temporal mosaic around you. Thank you so much for joining us on this deep dive. We'll catch you next time.